Throttling is a process by which BizTalk server ensures optimum performance and use of system resources. Being a middleware product sitting right in the middle of various connecting systems, it's important BizTalk got this capability. Floodgate scenarios were very common in a BizTalk server environment. A floodgate scenario is one where an unusual load comes into the system within a short period of time. Some of the common examples may include, like if you are working on a London stock exchange some kind of financial services, it's very common you get a floodgate scenario at the end of the day or beginning of the day when the market opens. And there are various scenarios depending on the industry. You will experience floodgate scenario into BizTalk server. BizTalk server manages the floodgate scenario by a mechanism called host throttling. It basically monitors various points in your system like memory, CPU usage, database connections, thread counts, etc. And if it detects a pattern, unusual pattern, then it tries to control those parameters to bring a system to a manageable level. We just highlighted some of the major problems surrounding around the throttling area. The first point is throttling is difficult to understand. Even for experienced BizTalk people, it's very difficult to understand. It's all numbers most of the time. So the raw performance counter data you get from BizTalk just gives you numbers. For example, number 2 is rate throttling. Number 4 is process memory throttling. Number 5 is system memory throttling. And also, it's not just those numbers. Once you see that number, then you need to dig deep into the specific area. For example, if it's process memory, then you need to go and understand what's the available system memory and how much your process is using, all those kind of things. So it's even for an experienced BizTalk person, it becomes a really difficult task to understand and optimize the system for throttling. Another important point is BizTalk server only provides raw performance counter data when it comes to throttling. There are no visual tools available out of the box that can give a easy clue to the end users to understand whether the system is throttled or not. The other problem we have noticed is as traditional performance monitoring tools like perfmon or loadgen, it's not designed to monitor throttling. It's not just simply monitoring a bunch of resources. You need to work out a relationship between various parameters, and it becomes a really tedious task. Unless otherwise you're a super expert, it is near impossible to understand the throttling. Another big issue we have seen is companies don't monitor the throttling conditions in real time. What we mean by that is before going into production, companies do a lot of performance testing, and during that they monitor the throttling and they tune the system. But once the system goes into production, nobody really actually monitors in real time. So the data what you got from your performance testing may not be in sync with what you're seeing in production. So you're just hoping your system is working in an optimal way, but in reality, it may not be working that way. So BizTalk 360 throttling analyzer is designed to address all these issues. Our end goal is to give a visual clue of what's going on in your environment in a near real-time basis. So we'll see a demo after this presentation explaining, going a bit more in detail how BizTalk 360 throttling analyzer can help. To understand BizTalk throttling in detail, let's take a sample scenario and try to simulate a floodgate within the application. So we got a application deployed called simple messaging. So it got a set of receive ports and send ports, and they got some matching filters for content-based routing. And all the artifacts are running within a single host, the default BizTalk server application host. And let's try to simulate a load condition within this application. We are going to use Microsoft LoadGen for simulating the load condition. If you're not aware what LoadGen is, it's a free download from Microsoft, which will help you to simulate various load conditions for your performance testing. So this is a simple LoadGen file, which basically tells you It's used for file-based transport, and this is the source location where the sample file is located, and this is the destination location where these files need to be placed. And also the stop mode is we have put the script in place so that it overkills the system for 5 minutes, so 300 seconds. And the various parameters like how many messages to put in a lot, and number of threads, and what's the sleep interval between the lot, etc. So basically, this script will overdrive your system, our simple application. Now let's go and run our script file with the LoadGen console application. It's very simple step. You navigate to the place where you install LoadGen, and pass the script file as a parameter to the console application. And let's start it. Okay, so it's firing messages based on the script we have defined, and what it's going to do is we should see some files coming up. You can see there's already 1,000 items flooded into the system. And if I go and see the task manager, this is it's a simple desktop, so it's not having enough resources, and you can see it's already struggling to do anything in the system. So it's just a typical floodgate scenario. So we are overdriving the system. If I go to performance, I can see there's a good CPU usage, but the memory is almost at its knees. There's not enough free memory and some paging going on. Let's run it for a few minutes, and then we can see like what's happening. As expected, the script completed in 5 minutes, and it just gives you the final statistics of what's been done. And you can see it fired around 5,500 messages within 5 minutes. We started off at 7:12 and completed at 7:17. And it fired at the rate of roughly around 18 messages per second. And we used 5 threads to drop off these number of messages into the system. Now let's take a look at the output folder where we are expecting these messages after flowing through the BizTalk environment. And you can see just by the timestamp, the last message received was around 7:46. So that's nearly half an hour after the final message has been dropped on the receiving side. So obviously, like if you got like a proper environment, we would have expected these 5,000 messages which we received in 5 minutes to be processed within 5 minutes or maximum 7 or 8 minutes. But in this particular scenario, you can see it nearly took more than half an hour to process the exact number of messages. So that's because BizTalk server applied throttling mechanisms, and it didn't process the messages as quickly as possible. That's good in a way because at least your environment was stable after this half an hour, and it didn't crash your server. So that's important for a very middleware product like BizTalk. Let's recap quickly what we have seen in this short video. So we have seen what BizTalk host throttling is, and how BizTalk handles a throttling condition by constantly monitoring various parameters like your process memory, system memory, database connections, etc., and maintains the stability of your system. And we also seen what are the challenges around monitoring throttling, why you need a BizTalk expert to understand what's going on. The main reason for us producing this video is to showcase what we have done with BizTalk 360 throttling analyzer that helps to resolve all the challenges we have mentioned in course of this video. In the next video, we will see the BizTalk 360 throttling analyzer in full action.